Hello and welcome to the video lecture on cyclic pattern generation of LEDs using 8051 microcontroller in embedded C. Now here we are going to simulate our cyclic LED pattern in proteus software. So first we'll go through the schematic of this. Now in proteus software I am using proteus suite 8.13 and here I have generated the schematic for the 8 LEDs. Now here I have taken the microcontroller AT89C51 and I am using the port P1 of that microcontroller. Then I have taken 8 LEDs and I have connected the anode terminals of each LED to the port pin, and all the cathode terminal of the LEDs, they are shorted together and they are given to the ground. So here we have connected all the LEDs that is given to DA in the sourcing mode. Now we'll write the program for generation of the cyclic pattern. For that I am using a kill software. So let's start writing the program. So first line is always you have to add the header file. So here I am going to add the header file reg51.h as it contains all the basic definitions of the microcontroller 8051. Then after that you go with void main void. We'll start writing our main program. Now here we are going to turn on the LEDs one by one with some delay. So first we will make the D0 positioned LED, that is the LSB positioned LED on, and then we will slowly move towards the MSB. So here first I will send the value of 0 0 or 0x00 to the port P1. So initially all the LEDs are in the off condition. Now in while one loop or infinite loop I am going to write my actual logic. Now this value the value first which I want to set on the port P1, that value I will assign to the variable x. But remember that I have not declared this x, so here first I will declare that x. So here I will declare unsigned character x. So the x contains the value 0x01. Okay, now I will use one simple for loop here because here we want to deal with the 8 LEDs. So I will use one for loop which will run from 0 to 8, actually 0 to 7, that means total 8, and in that for loop we are going to send the value. So now here I will write P1 is equal to x. Now with this statement what will happen? So initially my x contains 0x01, so that value I am going to send to the port P1. Now see here, when you represent the 0x01 value in binary, then how we'll write it? So it will be written as 000000001. So this pattern is actually going to make your LSB LED on. So when you send this value of x to the port P1, then the LED which is connected to the port pin 1.0 will be on. Now when this first LED turns on, then actually we are going to add some delay and then we are going to make the next LED on. So after this we have to write the statement for adding the delay in our program. So here for adding the delay purpose I am again using one single for loop. So I will write I is equal to 0 to I less than, I am just adding a random value, that is a 30,000 and I plus plus. So just put a semicolon, and now see here my first LED, that is the LSB LED is on. Okay, then I have added the delay and now I want to make the next LED, that is the LED which is available at the D1th position, that I want to make it on, right? So if you see the pattern, it will be something like P 1.7, 1.6, 1.5, 1.4, 1.3, 1.2, 1.1 and 1.0. So initially we have loaded the pattern 0, 0, 0, 0, 0, 0, 0, 1. Now I want to make this LED on. So if I want to make this LED on, then I have to shift this one towards the left. So actually here I am using the left shift operator in C, and now I am left shifting this entire pattern by 1. So I left shift this pattern by 1. What I will get is, now this 1 will be shifted here. So I will get 0 0 0 0 0 0 1 and 0. Again after this I will send this second pattern to the port P1, and again I am going to add a delay. Now after this again I want to left shift it by 1, because now I want to turn on this next LED. So again use the same thing. So for achieving this logic, now I am going to write the statement x is equal to x left shift by, and simply close all the brackets. So this is the first bracket for this for, this is the second, and this is the third bracket. Okay. So this is what is our complete program is, and here we have not declared this y and I, so I will just declare it. And my I is not a character but it is an integer, so I will define it as integer. Now I will save this program, cyclic dot c. Simply save it. Now add this program to this source file, add existing program. So cyclic.c is add and close. Now let's check the program for errors. There is one error in line number 18. Bracket. 13 number error. Here sample. Oh, 0 error 0. Now see, once again I explain how this code works. So here we have defined two variables x and y, and there is one more variable which is I for the delay loop. Now initially I have sent the value 0000 to port P1, because of which initially my all LEDs will be in the off position. Now in while one I have sent the value 0x01, I have given the value 0x01 to the variable x, and as I want to shift it for the 8 LEDs, actually I am using one for loop which runs from 0 to 7, that means total 8 times. Now in that for loop, first I have given the value which is given to the variable x, which will be assigned to port P1. So when the P1 contains, will get the value 0x01, the LSB or the P1.0 position LED will be on. After that we have added the delay, and after that delay now we have left shifted the value of x by 1, so that value or the x will now contain 0x20. So that value now will get loaded in P1, and then again there will be a delay, and again it will left shifted by 1. So when you again left shift by 1, it will be 0x04 will be the value. In previous case it will be 0x02, then it will be 0x04, and it will go on continuing unless it will reach the last value of 7, and all your 7 or 8 LEDs will be turned on one by one in the cyclic pattern. So now let us check the output of this program in Proteus software. Now if you want to check the output, you have to generate the hex file for this. So go to target 1, option for target 1. Here you change the frequency. Also go to output, create hex file, and again build the program. So hex file is generated here, cyclic LED.h. Now let's go to Proteus. Here you have to double click on this controller. Here also you have to change the frequency. So 11.05 megahertz. Go to program, and here on desktop go to kill projects folder. In objects you will get that cyclic LED dot. So here is a file, click on OK and simply run the simulation. So if you can see here, your LEDs are getting on one by one with some amount of delay. You can increase the amount of delay by adjusting the value in the for loop. So this is how you can design a cyclic pattern of LEDs using 8051 in embedded C. So if you have not subscribed to my channel, then please subscribe to the channel and please share the video with your friends. Thank you guys. Thank you so much.